All right, well, it's time to get started. I'm really excited to welcome you all to our today's webinar, co-hosted with and co-presented with McKinsey and Company on deep learning in finance. I have the great pleasure of being here with. I'm just going to share my webcam. Next slide. I have the great pleasure of being here with Vishnu Kamalnath. Hi there, Vishnu.
Hi, Hugo. How are you?
Very well. Yourself? Can we get the
I'm
next
doing
slide?
very well, thank you.
Fantastic. So today we're here, as we know, to talk about deep learning in finance. And so a bit about me. I'm, as you may know, I'm Hugo Bown Anderson from DataCamp, a data scientist and educator, and host of the podcast Data Framed. But we're not here for my expertise today. I'm very excited to be speaking with you, Vishnu, and for everyone out there. Vishnu is a data science expert at McKinsey and Company. And so today, I just want to give a brief rundown. Essentially, what we're going to have today is an insider's account into what has worked in finance, from machine learning models being used to classify fraudulent activity, to reinforcement learning being used for call center operations, to deep learning for credit writing and signature analysis. So we'll delve into some of these along with many other use cases. But before we get into all of this, Vishnu, as so many people have different journeys coming into the analytics, data analytics and data science space. So I thought maybe you could just give us the rundown of how you got into data science originally.
Sure. So the very elementary kind of analysis that I used to do was actually for predicting soccer outcomes. I am a big Manchester United fan, and back in school, I used to, have a lot of discussions with my friends about who's going to win different matches. And I started with elementary Python coding just to predict the outcome of different matches. But professionally, I started getting into it back in undergrad. So this is when I took my first AI course, and then I found out that the professor actually has a humanoid robot in his lab, and he wanted to really have undergrad students teach different kinds of machine learning techniques to the humanoid robot, and actually allow us to do research in computer vision and natural language processing. So I really, found the first course to be very insightful and exciting, and then the actual ability to experiment on a humanoid robot, which was a unique opportunity, and that's what actually got me into the data science field. And then it's been a wild journey ever since.
Yeah, that's really exciting. And I have a lot of questions around that. I'm just wondering why Python in the first place?
It was the easiest back then, and again, this is a high school kid, so I was never going to look at something like C++ or something more complex, because that would actually involve the software engineering side of things. So all of those memory management and things like that. And also, the data science community back then wasn't really involved with R that much, and this was about 10 years ago. So
Mm.
Python was sort of the de facto language. It was scripting, and so it had the right balance between anybody who could think logically would have the right tool to actually get the job done, and rather than working about the implementation details, you got to the algorithm directly. And so I found it as a good balance, and then the amount of tutorials that were available online were all in Python, so that sort of became my de facto language.
Fantastic. And we've seen, the community, the resources, and especially the community of packages, and the ecosystem of packages for machine learning and deep learning in particular grow a great deal since then, right?
Oh, absolutely. I mean, I didn't know back then that this would be a career, but it sort of ended up being one. And the packages and all of the insights and the community itself has grown just fantastically. If anything, R has made it even more accessible. R as a language is, they say it's a language designed by statisticians for statisticians. So it sort of takes even the next element of computer programming from Python and just focuses purely on the algorithms. So it actually becomes even easier for people to tinker around with algorithms today with R.
I agree. And in fact, R's really developing itself as an interface language as well. So you have JJ Allaire has worked on R Keras with Francois Chollet. So they have an interface to Keras now, which is gaining more and more popularity. So it's really exciting to see these different touch points with other parts of the community.
Oh, absolutely. Yep, I agree.
So we're here to talk about the applications of deep learning in finance today. I'm just wondering if you could give us the elevator pitch on deep learning, what it is and its relation with AI in general.
Sure. So deep learning ultimately is, I mean, it's not something like fundamentally new. At the end of the day, it's a branch of AI. It's basically neural networks. But neural networks have been around since the early 60s. It's been in and out of fashion for quite a while. The big renaissance of deep learning, if you will, or neural networks started back in about 2012, where you had what is the advent called convolutional neural networks. This is basically a kind of neural network that mimics the visual cortex of the human brain. So this is sort of how we as humans begin to interpret images. So the big insight was, rather than looking at a particular image and extracting specific features, you actually wanted to look at a region of an image and start extracting certain insights with the object and then what it surrounds itself with. So just as an example, between your regular machine learning or your regular feature-based vision and deep learning, let's say you want to teach an algorithm the difference between a cat and a dog. So with your, or back in the day with your computer vision techniques, you had a subject matter expert coming in and saying, look at this animal. Does it have fur? Does it have whiskers? It's probably a cat. Does it have a snout? Does it have a tail? It's probably a dog, right? So it's always limited to the human's imagination and the thought process. But what deep learning or this convolutional neural networks came around with is saying, let's flip the whole thing around. Let's actually say, show me all the images you have of a cat. Show me all the different images you have of a dog. And let me make my own interpretation of what a cat is or what a dog is. And so all of a sudden you have this whole field of computer vision that was dependent on features, and by features I mean things like edges and corners and all of those things. It's now became an automated kind of a process. And so you are no longer bound by the human. Instead, you have an algorithm that can tell a human being one of three things. The human goes with saying, that's interesting, but I always knew that. Or that's obviously wrong. There's clearly something wrong. It's probably overfitting or something of that sort. And then there's the third and the more interesting one, which is, hang on a second, I've actually never thought about that. And it's this sort of an approach where you increasingly see some of the articles that actually get a lot of the news attention. So things like when an algorithm beats doctors in accuracy for predicting tumors, or something like of that nature, you are exceeding the human level performance because now you're not having the human in the loop. And so that's sort of where deep learning increasingly goes from a computer vision standpoint. But when you look at it from a field like finance or insurance or any of those kinds of realms, where you have a lot more structured data, at the end of the day, it's your neural networks. But what they do is, previously your networks were just a single layer deep, and by a layer I mean a hidden layer deep. Now you have layers that can networks that go 5, 6, or even significantly further down. That's why you call it deep learning. It's literally the depth of the network. Right. And the reason that it's actually really important in finance, for example, is because you have a lot of correlated variables that you originally had basically univariate analysis done. And now with deep learning, you actually get the interactions between the different variables modeled in a substantially better way. And so those interactions is actually what plays out in a lot of the use cases in finance, or in other cases as well, that actually leads to the increased performance that we see with deep learning as compared to your regular machine learning techniques.
Fantastic. And I like that you kind of spelt out how deep learning works in a computer vision sense in terms of detecting edges and corners and this type of stuff and different features. And you also discussed, the amount of layers a neural network can have, and that deep refers to many layers. Because one thing that's really cool is that as you build more and more layers, you can see how the representation layers emerge, that you are detecting corners and edges or whiskers or these types of features as it gets deeper and deeper. So you gave a nice segue into deep learning for finance. And as we know, deep learning is being used more and more in the finance world. So I was wondering if you could just talk us through an example or two that you find interesting or illuminating.
Sure. So one of my favorite examples of using deep learning in finance was actually an engagement that we did about a couple of months ago. So this was one of the major banks in Latin America, and they had a phenomenal fraud problem. And the fraud was actually pretty unique because we've all heard of things like transaction fraud, credit card transaction frauds, or people trying to pretend to be other people, so identity theft and things like that. But what this particular bank had, and a couple of banks in this particular country also had, was very interesting. So you had the government of this country offering out pension loans. So this is basically for retired people. You could apply for a loan against future payments of your pension, given that your pensions are basically guaranteed by the government. And what the people used to do is that they used to apply for the loan in their own name. So if it was me, I would say it's Vishnu, and I go to the bank and I give my ID, my license, everything correctly. But when I sign the loan application, I'm going to forge my own signature. Yes, you heard that right, Hugo. We're going to forge my
Why
own
would you do that?
signature. Right. So interestingly, it's because when you go to the when it comes to the repayment period, I could always say, look, this is not my signature, somebody stole it.
That's a great idea then.
So it's plausible deniability. Now, the people that do this actually are pretty smart about this. So they don't forge their signature exactly because that loses the plausible deniability. But it can be so far off that anybody looks at it like, yeah, clearly this is not the same guy, right? So there has to be a little balance between the two. Now, when we first came across this problem, we were stumped. We had no idea how to solve this. So this was, again, a case where we were like, okay, we looked at all of the things that forensic science has done, and forensic science is really great at identifying if you're trying to forge somebody else's signature.
But not forging your own signature.
Right, but nobody's really thought about how do you forge your own signature. So what we did was
and this sounds, this sounds like a ripe space for deep learning, particularly because deep learning has been so effective in image recognition and computer vision, right?
Exactly. And the other big thing is as a feature discovery tool, because we didn't know what were the features that we needed to use. So this was a case where, again, like the cat and the dog, we were like, we have no idea what the signature looks like. You tell me what it looks like. So what we did was we fed in all the genuine signatures from this bank, all the customers, to this neural network. We again built a convolutional neural network. And then we fed the network with all the images that we've collected of people who forged their own signature. So the bank has had historically a lot of fraudulent incidents. So we collected all of that and fed that. Now here's where we found the most interesting outcomes, right? So the network analyzed all of this stuff and finally came out with a very, very good indication of people who forge their own signatures versus people who don't. So here's the problem. People, when they, these are regular people, these are not hardened criminals at the end of the day. So what they do is they get really nervous when they have to sign their own name, but in an incorrect way, when they have to forge their own signature. And like I said, it can be exactly the same. It can be too different. So they have to strike a balance. Now, they also get pretty nervous because they know that this has to go to the court. This will become a police investigation, so on and so forth. But they need the money. So what do? They end up tracing their own name as the signature when they do that. And the reason is because if it's your real signature, you've done it a million times. You just sign it really fast. But now you're trying to make a mistake. You're deliberately trying to introduce a mistake in the process. So this is what happens where they end up tracing the signature. And what that leads to is blotches of ink all along the signature, which was the top predictor that the network picked up.
And so you saw that emerge through the networks and see that in the representation.
Yes, very, very clearly. So you have people with blobs of ink all along the way where they pause. So if somebody has a lot of blobs of ink where they sign, it's an indication that they took a long time to sign. Now, of course, some people, older people may take time. That's an exceptional outlier case. but the vast majority of people were flagged correctly. So we went from almost a place where we didn't know what to do to a 97% accuracy in identifying, and this was the back testing, identifying all the fraudulent signatures that ever happened.
That is wild. Well, I definitely know that I'm not going to try to forge my own signature anytime in the future now.
Yes, and so I mean, in this webinar, the cat's out of the bag because now people know that that's basically what the network is looking for.
Yeah.
But we definitely never told any of the loan officers that this is what they need to look for. So we just automated the whole process because all it needs is one person to tell the customer, and then it spreads out.
Yeah.
But that was one of those cases where we had an extremely interesting example where deep learning significantly altered the way a bank worked.
Great. And I wanted to get to this later on, this idea of neural networks not necessarily, and deep learning not being interpretable models. But it sounds in this case, when you can get the representations out, there is kind of some rhyme or reason behind why the model's saying what it says, right? Like you can see the features.
Yes and no. So this is where deep learning has a reputation of being a black box, and I think for a good part of it, it is true. So again, deep learning is considered this niche topic, but in all honesty, it's just neural networks, and your interpretability really depends on the kind of neural network you're using. So convolutional neural networks, for example, you can actually have heat maps of the most important features, and it actually shows you these kinds of things. So, what we saw, for example, was overlaying a heat map to the raw image, and we found these dots all over the place, and we were like, oh, that's blobs, right? So that's how we found out. Now, in a lot of other cases for finance, so for example, the lifeblood of all banks, underwriting, right? When you look at underwriting, in the United States, for example, when you underwrite a loan, you have to be in compliance with the Fair Credit Reporting Act.
Right.
Now, in that kind of a scenario, you're not using convolutional networks, you're using multi-layer perceptrons, right? Just your run-of-the-mill networks, but multiple layers deep. If your network is probably a 1 or 2 layers deep, that's probably transparent and interpretable. But if it gets to 5, 6, 7 layers deep, probably not. And here's the balancing act that comes in, right? Because if your network is 1 or 2 layers deep, yes, it's interpretable, but then it's not really giving you a lift compared to your decision trees or random forests or things like that. And on the other hand, you have an extremely deep network, which probably does give you a lift. And in that case, it's not really interpretable, in which case the bank cannot use it because of regulatory concerns. So one of the things that, for example, we did, and this was another project that we worked with one of the largest investment banks, was underwriting their commercial real estate loan portfolio. So what we did was benchmark your logistic regression, which was what the bank used in production even today. We used a random forest, we used an XGBoost, and we used a deep learning model. And what we did was try to score the exact same data set across all the different algorithms. We scored it on AUC, the area under the curve. And what we found was that the logistic regression had a Gini of about 39. Your random forest and XGBoost were compatible at about 46 and 47. And deep learning had about 52.
Okay.
Now, if you think about it, each Gini point was worth about $5 to $10 million. So it was actually a pretty substantial amount of money. So the bank knew that it wanted to use the more sophisticated models, but it also didn't want to risk any investigation by the SEC. So what ended up, or FINRA. So what ended up happening is we used the XGBoost and the deep learning models as a feature discovery tool that sits in tandem with the logistic regression. So your deep learning and XGBoost were saying different kinds of features that your logistic regression just wasn't picking up. But you could pick those features up, and then you could manually introduce that into the logistic regression, which by definition makes it human interpretable. And then your logit gets the increased benefit. So what we found that the logit with the augmented logit actually went from 39 all the way up to about 44. So it's almost as good as your random forest and your XGBoost, but it's still your logistic regression. So by keeping the model exactly the same, just adding a couple of features from the feature discovery process, the bank was able to close the gap pretty well without getting into trouble. So this is sort of what we are seeing increasingly in the banking space, where your existing algorithms, your production algorithms for underwriting are not being changed from Logit to anything else. They're still going to be logistic regression models, which are very interpretable, but banks are using these more sophisticated tools as feature discovery as a feeding mechanism, as a feeder to your core Logit.
Great, in terms of feature engineering.
Yes.
Feature discovery. That's really cool. And I suppose I have one, I just want to make sure we're on the same page about what interpretability actually means. We're saying that we can say why a model makes the predictions it does.
Correct. So, for example,
and how do you make sure you're satisfying regulatory requirements? And like, how vague is the language, or how do you know that?
Oh, no, it's actually pretty specific. So, for example, if I reject a line of credit application from you, or if I lower a line of credit that you already have, for example, what comes out is I have to tell you exactly why I made that decision. So usually it's going to be a low FICO score, or credit report from TransUnion or something of that sort. So that kind of feature, the feature importance, actually shows up as the single biggest predictor. And then I put that as the reason in my letter to you. So it's not going to be random, variables. And each variable that goes into these kinds of underwriting models are extremely closely monitored. Now, all of that said, right, there are a lot of other cases where you don't really care about the interpretability, but you do care about the ultimate outcome. Another great example, for example, is in fraud detection. Let's say credit card fraud, right? You don't really care why the algorithm flagged something as fraud or not fraud, as long as you balance out the customer experience with the fraud detection rate. Again, at the end of the day, everybody can solve for fraud by just making sure that there's a two-factor authentication and all those kinds of things, but then your customer experience is really poor. So banks really want to manage the customer experience with the fraud detection. And at the same time, the fraud is basically a dynamic space, right? Because your fraudsters always try new vectors of attack. So it needs to be a self-learning kind of a model. So in this case, we've actually seen, models like deep learning and XGBoost and all those kinds of algorithms really sitting at the forefront for fraud detection. So it really goes on a case-by-case basis. And it's your models that actually are under scrutiny by the regulators, where banks shy away from these fancier techniques. But in other cases like marketing and sales, for example, it's all in, right? All of these players, and it's banks and other sectors, actually go all in, where they try to mine social media, they try to mine profiles or your comments, your lifestyle, telco data, shopping malls, all kinds of partnerships with data providers. They try to use that and build a more accurate profile so they can market things more accurately.
Right. And my understanding is that it's actually a function of nation as well. So for example, in Asian markets, deep learning can be used for credit underwriting in ways that it can't be here, right?
Correct. So in a lot of Asian markets, the regulators are still catching up. In the US right now, the regulators are pretty strict in the banking space. So is it in the EU. And so we definitely can use it in any of the underwriting cases. But in a lot of developing markets, it's still a possibility. And banks do use these kinds of fancier techniques for their core operations as well.
Interesting. So this deals with a lot of financial operations in general. There's also a lot of different type of work, such as call center operations, right, where we can see a lot of impact of these types of technologies.
Yes. So one of the actually funny that you mentioned that, Hugo, because we did a lot of analysis. We spoke to a lot of vendors and a lot of the players in the space for audio analytics in call centers. And we asked them this basic question. So why do I really need audio analytics when I could really transcribe the audio and then run your good old natural language processing on top of it. And the best answer we've got is your good old fashioned sarcasm. People are incredibly sarcastic on call centers. There's a big difference between, oh, that's wonderful, and oh, that's wonderful.
Yeah.
Right? And the amount of false positives and false negatives that you get from your NLP techniques on transcribed text is just outrageous. And so increasingly, we've been seeing a couple of these techniques being used in call centers, for example. So where we look at the tone of the voice to identify the underlying emotion. So if a customer increasingly seems angry, then depending on the customer LTV and how important the customer is, etc., you would have a supervisor step in almost immediately. It's also a way to actually gauge your agent's performance. We know that your top agents actually do remarkably well, significantly better than all your other agents. In fact, the 80-20 gap is actually pretty substantial in call centers, for example. And so what do they do differently? And so we've also started seeing these kinds of automated solutions that analyze the first word that your top performers say. Do they greet your customers by a hi or a hello or something different? And what is the average tone of the voice? Do they shift it? All those kinds of things. There are a couple of providers that actually analyze more than 600 variables on every single call. And they actually analyze all of that and say, what does a successful call look like? We're also seeing a lot of deep learning in the back-end operations. So things like contract compliance, for example. Previously, you needed an army of paralegals to review your contracts and make sure that everything was in order. Today, you have all of the OCR that actually ingests all the data, digitizes it, and then you have NLP and deep learning techniques that process all of that, do the entity identification and mapping, and then make sure that the contract is in compliance with everything else that the bank policies state. And also automatically populates the database. We've also seen some more exotic use cases. So, your investment reports, analyst investment reports are actually not written by analysts anymore. They're actually robo-writers. So they actually have recurrent neural networks to generate the text and just have placeholders inside that say, all right, you should probably buy X stock or sell Y stock. And those recommendations are just fed in. But the actual sentence structure is written by algorithms as well.
Great. So we're going to go to some questions from the attendees soon. So if you have any questions, do drop them in now into the chat, and we'll try to get to as many as possible. But this has been a really nice, I think, introduction to the space as it currently stands. And before we go to questions from the crowd, I'd like to know what the future of AI and deep learning in finance looks like to you.
The future, wow.
That's a prediction question.
Right, exactly. So I think there's going to be a couple of different things. The first one is you're going to have significantly more accurate algorithms, and that's just because of a function of the data, the quality and the quantity of the data, and the infrastructure. So we have banks going into the cloud computing and GPU computing. And then you also have all this humongous volume of data that's going in. So you're definitely going to get a lot more accurate algorithms, which is going to lead to a much better customer experience. You're going to have, more accurate marketing techniques. So this is, again, where your pricing is a big differentiating factor for a lot of people. You also have your risk reduction pieces. So things like collections is actually a big value lever for banks. That's going to get increasingly more automated and increasingly better because of more accurate data and how to treat customers who are delinquent. You're also going to get a lot more things that actually keep employees' behavior in check. So your internal conduct risk management, for example, is a big thing that a lot of banks are looking at. And that's, again, getting increasingly better with AI. So I would say the future of banking is going to be a lot more personalized, a lot more customized. And at the same time, it's going to lead to a lot better customer experience for a lot of people.
And what do you see? as being the data skills, like not necessarily for data scientists and people, technical professionals, the type of data skills and data knowledge that we'll need to see spread across different levels of organizations in finance or banking.
Sorry, could you say that again, Hugo?
Yeah, so for example, I'm just going to I've got my audio coming through my own headphones, so I'll take them off for a second. What type of data skills do you think people who manage data scientists will need to have, whether it's knowing about the basics of machine learning, supervised learning, different metrics of model performance? How much will people who aren't data scientists need to know about the technical stuff to do their job going forward?
So moving forward, what we as McKinsey generally say is, out of all of the people in the value chain for analytics and analytics-driven organizations, the single biggest and the hardest role to hire is what's called a translator. So this is the person who would have sufficient business knowledge and sufficient data science skills to act as a bridge between the two. Because your data scientist isn't going to understand why they're building these models and what the practical implications are. And your business wouldn't know what machine learning really is. It's a magic crystal ball for all they care. And so you need somebody who speaks both languages. And at the end of the day, a person who manages this, or a person who leads a team of data scientists or a translator, would ultimately need to have significant domain knowledge, because what we've consistently found with all of the experiments and all of the work that we've done is that machine learning or AI in general can never be hands-off. You really need context-specific domain knowledge and build the AI algorithm for the job that to be done. And so you absolutely need that domain knowledge. That's very critical. The data science skills, increasingly, I would say a lot of the tools are getting commoditized. And so there isn't a lot of value coming in from just knowing the algorithms. But where the real differentiating factor comes in is knowing the math behind it. So if people are thinking about being hobbyist data scientists, that's great, but it really needs to be backed up by some core quantitative training so that they understand why the algorithms work the way they do. But for a manager, again, they definitely need just a hobbyist level of understanding, just so that they can have a common sense check, if you will, about why the algorithms behave the way they do.
Great. And I love that you mentioned this burgeoning role of data translator, because I actually spoke yesterday with your colleague. I don't know if you know this. I hope I pronounce her name correctly, Jayanthi Rajamani, about doing a webinar and coming on the podcast at some point to discuss data translation and her thoughts about this, and among other things. So that's really cool. So we've got some questions from the crowd. Let me just, yeah, this is actually a slightly technical question, but from Robert, we have, if you don't have any coding experience at all, but a big finance and stock market interest, which programming language would you, Vishnu, recommend to start learning with?
If you definitely know your industry experience, I would recommend R as a good introductory language, only because it sort of obfuscates the computer management side of things. The problem with getting into some of the other languages is that you would have to manage the programming side with the algorithms, and it sort of detracts from the learning. So using R, again, like I mentioned at the beginning, R seems like a language by data scientists for data scientists. It allows you to just focus on the algorithms. And a good thing about R is the community is super active, and it has already released a lot of libraries. So you can actually get down to the actual hands-on implementation almost immediately. And it's all open source as well, so you don't really have to pay any money to play around with it. So I would go with R. And then once you get increasingly comfortable and you're stepping up into the more professional realm, and by professional I mean more like productionizing algorithms, then I would probably add Python to my toolkit. Also because a lot of the core libraries that you would have heard of, for example, TensorFlow, does interface a lot with Python, and so using that would definitely be a strong skill set. And then I would also brush up on my SQL to make sure that that's strong as well. And so a combination of R, Python, and SQL And I think from a language perspective, you're almost there.
I think so, and I actually think your statement of I'll reframe it slightly, but R has such a lower barrier to entry for a lot of people interested in starting in analytics and data science in general, and particularly with the advent a lot of the tidyverse tools such as dplyr and ggplot2 and it being developed as an interface language to a lot of other packages. So I have a question from Adil. Adil quotes you in, you said earlier something along the lines of deep learning enables modeling correlations substantially better. And can you clarify what you mean by substantially better?
So correlations, for example, like let's take an example of you're trying to predict the odds of somebody having a disease, right? And so you're trying to say, does this person smoke? Does this person drink alcohol? Does this person seem overweight? Does this person have XYZ characteristics? The thing with MLPs or multi-layer perceptrons is that as you go further down the network and as you increase the number of layers, it starts to mix these different variables. And that's why you have by definition, your neurons, they actually start combining the functions in the input functions. And so it actually, by definition, does a better job at it. Now, is it really worth it from a accuracy or a Gini standpoint? That really depends on the context. So substantially better, what I mean is in a couple of cases that we've seen, your one single factor, your univariate analysis doesn't really hold true, but the confluence of 2 or 3 factors, when all of them are present, actually is indicative of certain customer behavior. And this is something that we've observed in marketing engagements and also in cases where we're trying to predict fraudulent transactions, where 1 or 2 factors don't really mean much, but when all 3 happen in certain patterns, in certain sequences, things like that, the odds of a behavior happening is substantially higher. And by substantially, I would say a good 20 to even 50% higher than your regular customers. So that's what I mean by that.
Thanks, Vishnu. We've got a great question from Andrew, which is, are financial institutions pivoting away from old school econometrics techniques for prediction to machine learning models?
Yes and no, right? So again, if it's something like with your underwriting or anything that's heavily regulated, we've again seen banks that don't touch it with a 10-foot pole. The only thing they do is they're willing to use fancy techniques from a feature discovery standpoint, and even that we've seen risk coming in, legal coming in, and then double and triple checking all of that before we actually go and move that into production. So in those cases, no, we're definitely not moving from your logistic regression away anytime soon. But in other cases, like your core operations, marketing, back-end office work, call center operations and optimization, fraud detection, all of those things, absolutely. They are definitely pivoting away to the newer techniques.
And these are aspects of the work which will impact a lot of other verticals as well, right?
Oh, absolutely. So, I always say that this whole new wave of AI, and I'm sure everybody agrees on this, is actually the culmination of 3 factors. It's not just the algorithms. In fact, algorithms get all the press and the media attention, but it's actually a combination of increasing data, and that's the IoT revolution, increasing computing horsepower. So this is your cloud computing, your GPUs, which actually spurned the whole wave of deep learning, and then your algorithms. So it's a combination of these 3 that is actually powering up this whole new golden age of AI, if you will.
Yeah, I like that framing of it. So Nareem, I hope I pronounced your name correctly, Nareem has a question. Do you, Vishnu, see Python skills replacing Excel skills for the average financial analyst?
No, not at all. I actually think it's not going to be a replacement. I think there is no, Excel is not going to go anytime soon. In fact, a lot of investment bankers still use Excel. A lot of the financial cash flow modeling and all of those kinds of things are still with Excel. So I think increasingly bankers will definitely pick up Python. And I think the delta is actually pretty small. Because if you think about it, whether you pick R, Python, whatever it is, computer programming at the end of the day is just translating pure logic into a language. And it doesn't matter what that language is. So for example, a good analogy I can give you is for those of you who are familiar with Alteryx, right? Alteryx is a drag and drop UI interface that replaces programming. But so you're not really writing any code, but you're actually, for all intents and purposes, writing a program, which actually does a lot of things for data pre-processing and even actually algorithm generation. So when you think about it, right, it's more a question of, yes, I need to do X, Y, and Z. And whether I do that in Excel, whether I do that in Python, as long as you have a clear understanding in your own head about what needs to be done, the language is actually the easy part.
Thank you. We've got a good question here from Omar, and Omar is asking, what advice would you give to a data scientist who would like to get into this field? What are the core essentials to get your foot in the door? So I think what Omar's getting at is someone who is proficient at data science, but doesn't know much about the finance side of things.
So that's basically where I came from, for example, Omar, and everybody else. Right. I'm an engineer by training, so I didn't actually come in from a financial background. And I think the financial side of things is actually not that difficult to pick up. It might take a while to actually learn a little bit of the jargon and things like that, but there's a lot of resources out there, like Investopedia, for example, that's actually going to give you a pretty good definition of what each term means and the related terms. So you actually go through that and keep learning about it. The other real thing I would practically recommend, right, if you're actually really good at the data science, is to get involved in some of the competitions and get your skills up and running with something real. So a great recommendation I can tell you is Kaggle competitions. So what I do, for example, in my spare time is to actually go with a couple of Kaggle competitions, which talk about the metrics that the specific sponsoring company needs to be beaten. And so you can obviously build the algorithm and score yourself against some of the best people in the world, so best data scientists in the world, and then simultaneously go on Wikipedia and start reading up on, okay, well, what does that metric mean, and what are the other metrics that go with it? And so, for example, I remember my very first Kaggle competition was actually trying to predict the risk of a person defaulting on a loan, and this was before I joined McKinsey. And this was actually, I think, in grad school. So I actually didn't know what PD and LGD and EAD and all these terms meant. But then when I actually, found out that, okay, probability of default, that kind of makes sense. Yes. Now, what does the rest of the terms mean? And then, I played around with Excel, I played around with Python and all of those things and got a grasp for these things. And then ultimately, truth be told, you really need to do a project to get your hands dirty. And then that's when you really realize what these metrics truly mean. So I wouldn't get too hung up on it. Finance is the easy part. Data science is probably getting really good at the data science is probably the harder part.
Yeah, absolutely. And I do think I'd always tell aspiring data scientists or working data scientists trying to get into another discipline that project-based work and just doing all the steps and figuring out what tools and techniques you need around every piece of the analytics pipeline is the important thing to do. So we have a final question from Bren. What is the state of reinforcement learning in this space? So we hinted at this briefly. I'd like to reframe that slightly by asking where it is now and where do you see it going? Maybe in terms of, will there be more adoption of it in the future?
I am of a little bit of a mixed bag in reinforcement learning in the financial world. So where we are seeing this quite meaningfully is in things like call center optimization. So, financial call centers, you have a lot of different metrics that you want to optimize on. One of them is the staffing level, but then there are other things like, especially outbound marketing calls, you really want to have the customer and the agent click, if you will, and that's based on their behavior. So you have all of those kinds of optimizations where we've seen reinforcement learning actually performing really well. Some of the other areas that I've seen are more on the fringe side. So, like stock market predictions, you really want to start looking at reinforcement learning on what is the optimum trading policy and things like that. Those are some of the cases where we've actually seen reinforcement learning. But by and large, in a lot of your regular retail banking or commercial banking, I haven't really seen a lot of reinforcement learning. That said, there is a lot of opportunity for it probably in the future, but that's my read on the current state of reinforcement learning in the field right now.
Thank you very much, Vishnu. And I just want to thank you on behalf of everyone who's attended and everyone at DataCamp for joining us on today's webinar, and thank all the attendees as well. And you can get in touch with us on Twitter at DataCamp, MCK Analytics, and at Hugo Bown as well. So thank you once again, Vishnu.
Thank you, everyone. It was a pleasure.